Well, good afternoon, good morning. Welcome to our webinar. I'm Stan Brubaker, President of Beyond, and I will be your host for today's webinar. I'm excited to share with you our new EdgeXConnect No-Code UA Server. We believe it is truly a game changer, providing an off-the-shelf solution, configurable no-code UA server as an alternative to building custom UA servers. The webinar is provided by Beyond in cooperation with Umati. Umati promotes the OPC UA machine tools standard information model that we will be showing in our demonstration in a little bit. There's a couple of key things that I'd like you to keep in mind as we go through this webinar. First, no-code solution. What you will see was developed, configured with no code. You can, at the end, you'll see where you can get a download of a trial version, fully functional, EdgeXConnect, and you will be able to do exactly what we're doing in this demonstration without any code. You'll be able to model your equipment and run it in simulation in a matter of minutes. It's flexible. It can, with our EdgeX Studio, you can import any information model and you can configure any machine that you'd like to model with the information models using our EdgeX Studio graphical modeling tool. And lastly, it's connectivity to any device, protocol, or equipment with plug-in adapters. And with that, you get easy mapping of I/O. That's part of the adapter. So again, no code, you can bind to all your I/O through the EdgeX Studio. So those are the three key points I'd like you to keep in mind. No code solution, flexible with any type of information model and modeling, and easy connectivity to any type of equipment and protocol. Although the webinar is scheduled for 45 minutes, we expect with Q&A it might go a bit longer. I appreciate if you can stay with us at least till we get to the Q&A, because at the end we'll be sharing some next steps and how to get the EdgeXConnect so that you can start using it. So quickly, two introductions and the agenda. Again, I'm Stan Brubaker, President of Beyond. With me, the other speaker is Costantino Pipro, or Cos for short. He's our CTO and co-founder of Beyond. And we have two panelists with us. Larry LeBlanc is the Director of Marketing and Business Development for Beyond. And last but not least, we have Gorish, representing the German Machine Tools Builders Association, and Umati. Goetz is very familiar with machine tool standard and also very familiar with and skilled at implementing OPC UA servers. So he understands this technology very well. So Beyond has been providing OPC UA servers for 6+ years. I mean, that's been a focus of our business. We really focused on services in the beginning. And through that, we discovered that the challenge was customers wanted UA servers cheaper and faster. And it was always a business challenge for us trying to meet their expectations. And through a number of projects, we began to realize there was a simpler way, a more off-the-shelf way. And with our experience, we decided we were going to build a configurable OPC UA server so we don't have to start with a development every time we want to provide a OPC UA server. And going forward, that is where we're putting our focus is on EdgeXConnect as a technology, as a product to satisfy the OPC UA requirements in the marketplace. A few things on logistics. I'm going to start a poll right now, and you'll be able to respond to that poll. And it's just to get a little bit of information from you about your interest in OPC UA and where you are in adopting this technology. There will be another poll at the end when we get to the Q&A that's feedback on our webinar. We'd like to hear how we did in the webinar, and we'd appreciate your feedback. And there's one other thing. You should see a hand well, there's a couple other things. You should see a hand at the bottom of your screen. If you can just maybe touch your hand now, put up your hand, let me know that you're hearing me okay. Yep, I see some hands going up, good. All right. And then also very importantly, you should see a Q&A. And if you hit your hand again, then it'll take it away. And then you should see a Q&A button at the bottom, and that's important because we want to hear your questions. And we'll be answering questions throughout the webinar. And when we get to the end, we'll have a time for Q&A as well. We'll probably push some to the end depending on what is required as an answer, but we'll try to respond timely as we go through the webinar. I'm going to set up the kind of the background on EdgeX, why we have EdgeX, what's the justification for using EdgeX, and then an overview of what EdgeX is, pieces and parts. And then I'm going to hand it over to Costantino for a demonstration, and that will be a good part of the webinar. And it is a technical demonstration, but we are dealing with a technical product, so it's hard not to be technical. But I think if you remember the 3 key points that I mentioned in the beginning, it'll help solidify those points as you see the demonstration. So why EdgeX? EdgeXConnect, EdgeX for short. Time, cost, and developer experience. That's the primary reason. Those are the biggest challenges to developing or adopting an OPC UA server in the traditional way, which is buying an SDK or acquiring an SDK and developing a custom UA server. With EdgeX, we offer an off-the-shelf, no-code option to address these challenges. We really believe that with this off-the-shelf solution that the adoption will increase dramatically in the marketplace. There's a lot of machine builders that don't have development resources, don't have large budgets, and EdgeX is a good fit for those that want to acquire that standard, adopt that standard without the large cost and time required to develop a UA server. If you buy an SDK, it can range from $7,000 to $15,000, and we've done projects anywhere from $40,000 to $200,000 in development costs. So it is very expensive, and it requires a lot of expertise. When we started, I think there was 12 parts to the specification, OPC specification. There's now 23. It's an evolving standard, even though it's been around for some time. So a big benefit in having a product, you stay current. The product evolves with the standard, and you're always staying current without having the large cost of maintaining your own custom solution. Okay, my last slide, just to give an overview of the solution of the product. EdgeXConnect is what we call the product. That's the complete package. That's all the components. The complete software offering consists of EdgeX Studio, which is the graphical modeling tool, which is the configurator. It's what configures the EdgeX server. It includes the I/O mapping. EdgeX server is the server that runs in the background, and that is the OPC UA server. It ingests the information model that's provided by EdgeX Studio, and it maps to the device I/O per the configuration in the EdgeX Studio. And then we have the adapters. The EdgeX adapters are what allow you to connect to anything. We have a number of them off the shelf available now. We have OPC UA, Modbus, OPC Classic. We will be adding to that library, I'm sure, in the coming months. But we do offer a SDK, so vendors can develop their own adapter. It's not a big effort, and it does not require any OPC UA expertise, which is a very important point there. Yeah, so those are we're Linux, Windows, run on various ARM devices, Raspberry Pi. So we run on small platforms, and as shown in the picture, as you can see here, we have Studio as the configurator and the server with the adapters. And Studio, or the server, can be spread across different devices and have Studio be configuring them. So you can have Studio running on Windows and have it connecting to your servers that you may have several potentially across your equipment or environment. So that gives an overview of what EdgeX is and its components. I think the next slide is, if I can get to it, there we go. So the next part is a demonstration. So let me fire that up. It's a video. I'm just going to run it, and then we will answer questions, and we can go into the tool if necessary after.
Well, in this demonstration, we're going to do a few things before we start doing them. I want to go through the script of the demo. There's going to be a couple of components in play. The one thing that we're going to be using is the EdgeX Studio, which is the modeling tool by which we can configure a model, information model, import companion specification, define the address space, the I/O mapping, and everything that we need in order for us to deploy a running EdgeX server runtime. The runtime itself is on a separate machine, and it will use whatever configuration we create or change with Studio. So EdgeX Studio runs on my Windows desktop. It can run on Linux desktop too, but in this case, just to see variety, I'm going to use my laptop, whereas my EdgeX server is running on a Linux machine, which is in this case hosted on an Amazon instance. So it's remote from my location. Once I deploy a configuration to the runtime, I can then connect with the UA Expert, which is a generic OPC UA client. Many of you will know it. It's actually made by Unified Automation, and we can verify that the configuration and the server and the values are behaving as expected. In the runtime, we have a few options to map to I/O devices. Some of the adapters we provide with the default installation. Other adapters can be created with the adapters SDK, or third party can install them. But for the purpose of this demonstration, I'm going to use mostly the internal simulator that comes with EdgeX, that just does random values, actually counters. And I'm also going to connect to a Modbus TCP simulator to simulate a Modbus TCP connection, where I can read and write the values from a Modbus TCP slave. And the other connection, there is an OPC UA server on the internet, which is maintained by the Eclipse Foundation, and that also exposes some OPC UA tags that change randomly. So we can show how EdgeXConnect can also connect to another OPC UA server and relay the information that way. But the key part of this demonstration is the fact that EdgeXConnect is currently the only technology that allows a user to import an existing information model from a companion specification or from a private endeavor import it into the model, create instance of that standard model, and then map it to I/O and deploy without having to write any code. And that's what we're gonna do. I'm gonna fire up Studio. I'm gonna import the running server configuration. Now this server has been installed right away, so it just runs the default installation address space. There's no particular model in it. But I'm gonna make sure that the running server model can be imported in Studio so we can see it. And then we're going to make sure that an OPC UA client can connect to it before we start any modification. Then I will go ahead and get the umati companion specification and the node sets that are publicly available on the internet. Once I import the companion specification, I will then create an instance of a umati object, like a tool, a machine, some sort of equipment that is modeled after the standard. Creating an instance will allow me to map some of the variables of that instance to some I/O. In my case, I will use a Modbus register and an OPC UA tag from the Eclipse Milo server. And then I will deploy that server to the EdgeX runtime, and I will verify that the client will then see the new configuration. And this will demonstrate how easy and painless it is to add OPC UA to an existing solution with the information model and the standard companion specification. So I'm going to close the slide and get to the actual software. There you go. So the first thing I'm going to do now, I'm going to launch EdgeX Studio in my Windows laptop. That will start this desktop application. And in this desktop application, I'm gonna I could create a new model, but the easiest way is to connect to an EdgeXConnect runtime and import the configuration from it. To do that, I have to make sure that in the general settings I configure the IP address, which I already prepared here. It's my AWS instance. When I will connect to that IP address, I will basically reach my Amazon system, which I can control here in this shell. And this Linux machine is an Ubuntu image, and it's running the EdgeX runtime. I can verify the status of my runtime with common Linux administration. In Windows, it will be a different architecture in which we use Windows services, but in this case, we're using Linux daemons. So there you go. So my EdgeX system is running. There's some information about some of the services being loaded. So it looks like my EdgeX runtime is running, so I can save this configuration, and when I go and import that, Studio will make a connection with our proprietary RPC and import the model. The model that gets installed by default in EdgeX runtime has just the OPC Foundation types for the OPC UA specification, and we also include a test object node with a number of variables that are currently mapped to our device simulator. That what the device simulator does, it's the only device that is pre-installed. The user can then delete when they actually map to real I/O. But for demo purpose, when you install the software, you can see values running, and these values just counting up from a given number. If everything is working correctly, I can connect with an OPC UA client to that machine and see these values. So I'm gonna fire up the UA expert tool, which is a tool by Unified Automation. General purpose client, I can connect to the server, which is this server in the list of things that I have here. And the client can see the endpoint, which is running in the cloud in this case, and I can choose a different security policies and authentication. For sake of speed, I'm gonna go with an anonymous connection with no encryption, and as I connect to it with the client, I should see the address space. You got a little warning because of the latency of the network and everything, but once the UI expert can read up the address space, everything is going to be okay. So the test object is that object that we saw in the model, and it implements these variables, and when I subscribe to the variables, it will initiate the simulation, and it will count up values. They actually values, structures, methods, just to have something to start with and modify, a little bit better than starting from scratch. So now I know that everything is working. I can disconnect the server. Nothing happens if I keep connection, it's just pointless. So I have this information model. The next thing I want to do, I want to import the umati companion specification, and I will do that by going to the internet and getting the public companion specification. So in order for me to get the necessary artifacts, I will need to first of all go to the umati website. Go here and I look for downloads, and there's a number of materials, including information for the developers, which one is the specification and the information model about the machine tools. It's downloadable from this location, the OPC Foundation. I already did that, and it's in this PDF. In the PDF, it goes on describing what the specification is about, what use cases it responds to, and then the whole OPC UA structure of things. But the one information that I want to point out now is that when it comes with implementing this companion specification, I have to take in consideration that the information model uses other namespaces, namely some of the other standards. That's very common in the OPC UA working groups, that when you create an industry standard for a specific vertical, you might base it on a more general purpose initiatives rather than starting from scratch. In this case, I can see that this information model will require the device integration information model, the machinery information model, the industrial automation information model, and eventually its own namespace, which is defined by this specification. So I will need 1, 2, 3, and eventually 4 node sets. The node sets are basically the XML realization of these specifications, so that softwares like EdgeXConnect can use that information model in their implementation. Now, EdgeXConnect is the only one that can import specifications and create instances automatically without coding. But in order for me to get the node sets, I have to go to the GitHub repository, which is basically a collection of node sets that is maintained by the OPC Foundation for all the OPC Foundation working groups. Other companion specifications might be created by private companies, other committees, and they will publish their own node sets. But in this case, I'm going to use the publicly available things. And since I need the DI, IA, machinery, I go to the public GitHub, and I will basically clone the repository. They're here, and I can see the DI, node sets, and the rest. So I'm going to go ahead and, following the indication of the dependency in the specification. I'm not spending time explaining the specification, the umati standard and all that. That's for another time. But I'm going to go back to my EdgeX Studio and start importing the necessary models. The first one is the device integration, the OPC UA DI Companion Specification, which is in my UA node set repository. This guy here. And in the DI, I'm looking for a node set 2 file, which is the XML representation, this file here. And I will import that model. When I do that, two things happen. Once I get a new namespace, which will include all the types defined by the DI specification, and also they define some instances like this object, like network set topology. You can see that the namespace is DI, as opposed to like our test object, which is our test model, and or the OPC Foundation primitives. So after the DI, I will import the IA industrial automation model, which is right here, and then we create other objects. I might not see any instances in this case, but I will have IA types in my address space. Then it's required to import the machinery specification, which that's another node set 2 file. We're gonna have videos on what node sets are and things like that, or you can see that information on the OPC Foundation side. So now I also have the machinery. The machinery introduces new types, data types, and objects interfaces, but also a folder that contains the machines by which you organize your instances, and you can see that that's the object. And finally, I can now import the machine tool. Sorry. Machine tools, latest specification. Open. And that creates the machine tool namespace. So now I have a full umati compliant address space with objects that are relevant to what I'm trying to do. And you can see that I have a machine tool type here that is part of the machine tool specification, which you know, if I read the specification, you can see all the variable types that are modeled there. So all the documentation is provided in that objects in that document. So now that I have all the type definition that I need, all I need is to create a machine or a machine tool. Now, one easy thing that I can do for sake of time, I can actually import another model, which is not a companion specification per se, but the good and clever umati guys also gave me a node set that contains an example of a machine tool. I'm going to use that instead of spending like 10-15 minutes creating objects and variables. And that's another powerful part of EdgeXConnect. Even instances or user-defined things can be imported, and there it is in the user space, namespace. Now under machines, I have a couple of cool objects. One is the sample machine tool. We're going to look at that, which is defined according to the specification and has the type definition of a machine tool type, which contains a number of objects, productions, production objects. What is the program? What is the state? And different state information. But more than anything, it contains these variables here. And these variables that I personally don't I can guess what it is, the number of the state number in the list of numbers. The operation mode is probably either enumeration, yeah, it's probably enumeration. But this number in list, or this name, the name is a string. I can see that this number in list, it's a variable, and it's an unsigned integer 16. And it doesn't do anything. It's expecting you to actually map this object to a true machine tool that has a program running, and you map the variables and the properties to your particular underlying system. In EdgeXConnect, you do that by mapping a variable or a property to an IO data source. And I'm going to just take this number in list unsigned integer 16. I'm going to make it writable. And I'm going to map it, just for sake of ease, to our device simulator. The device simulator is the internal simulator that comes with EdgeXConnect. It's the only device that I configured so far. And what it does, it doesn't have any data, because what it does is just it takes whatever number and it just counts it up. You've seen it at the beginning of this presentation. I'm going to save this just to make sure that this kind of model can be then deployed. Pressing this button is basically deploying the configuration to the runtime system. And if everything goes as planned, I will be seeing quite an interesting change in my runtime address space. So the server is being restarted remotely. Yeah, I didn't need to do anything. The UA expert can now try to connect to my Amazon. Well, no, it cannot connect yet, and the reason is because it's probably still restarting. That's okay. It takes a few seconds. It's actually a remote machine, so we'll give it another try. There it is, and now I can see, well, can see the difference. I can still see my test object, which I might eventually delete. But I now see my machines, and my machines have things in it, like my sample machine 2. I actually don't remember what I mapped. Yes, the production set. So if I go under production, active program, and if I see state, probably that does not map to anything. Well, it is mapping to something, but it's probably not changing much. But this number in list number, yeah, it's actually mapped to the simulator. Now it's mapped to the simulator. I can probably write to it, and it's overriding the simulator. Yeah, eventually it's going to count random number. Okay, so I'm going to leave it running. It's going to freak once I restart, but that's okay. So let's do something a little bit more interesting. In my in my Linux machine, I also have a Modbus TCP simulator. It just simulated a Modbus device, and I wanna be able to map my number in list unsigned 16 to a Modbus registry. So I go to the EdgeX Studio and I create a new device. When I do that, I basically tell the EdgeX runtime, go ahead and load an adapter. Let me call this device Modbus TCP device. And the adapter of choice, these are the ones that ship with the EdgeX, is the Modbus TCP. The pool size is just an optimization for the communication, and it's like, puts the reader writer in threads. I'm gonna put 5. That's relative to the power of your platform. It's a Linux machine, so you can probably handle a few multi-threads. And then there are specific configuration parameters that are relative to a Modbus connection. The IP address, the port, the slave ID, and also advanced features like the endianness, the swapping of bytes. Anything is Modbus. If it were a different simulator, like needs an adapter like the RTU, which is a serial device. It will have a serial port device. If it's an OPC UA client device, which we are going to use it has a totally different set of parameters, and that's the powerful and flexibility of the adapter framework of EdgeXConnect. It allows us to use those adapters or create our own, and especially in OEM where they have proprietary I/O system, they can create an adapter without knowing anything about OPC UA. It's rather simple, and the configuration is extremely flexible, so you can pass whatever parameter your I/O system needs. But the TCP adapter, I'm going to keep it default because the Modbus TCP simulator actually runs on the same machine, so it's localhost. The port is the default, slave ID is 1. I'm going to save this. Now that I have the Modbus TCP device, I can take my numbering list and map it to a register. It's an unsigned integer 16, so it's going to probably take one register in Modbus. So the GUI changed slightly because in a Modbus register I need to tell him, well, it's an analog. It is a holding register. I have to know something about Modbus. It's the address of the holding register. The read function is read holding registers. I'm not going to teach you Modbus. You probably either know it or you can look it up. And also other advanced things that you might be interested in when mapping to an I/O, which is I might need to scale from a raw value to an engineering unit. My device might give me like voltage variation, and I want to just scale to engineering units linearly or otherwise, and that's it. As I said, every adapter has its own parameters depending on the nature of the adapter. For a Modbus device, these are the ones. So I'm just gonna put holding register 1. The Modbus simulator doesn't actually do anything to the value. I'm gonna save it. I'm gonna deploy. But what I can do is I can show that it reads probably a 0, but if I write to it, the write is going to be successful. It's going to write to the Modbus, and I probably have some logging. Yeah, there you go. The Modbus simulator, it will detect if I'm doing stuff to the register. So the server should be restarting in a few seconds. I'm going to connect UA Expert. One thing I can notice on my other monitor, you can see that actually the adapter is talking to the simulator and it's actually connected. And if you count the number of connections that this TCP server has, it's 5 because it's my pool size. Oh, somebody started reading some 1. Okay, register 1, and it's probably this guy, which I actually did not disconnect the server, so it's reading that value. So if I write to it, yeah, it's sorry, what did I do? 99. Enter. So the writing is successful, and I can see that write holding register was successful. That's pretty good. It demonstrates the fact that I can read and write from Modbus. Is not that exciting because the simulator does not actually move anything. But what I can do now to get a little bit more interesting is I can add a variable on my own, as a user would do. And I'm going to add a variable to this model. The namespace is going to be the tool sample. The ID type is numeric, but the browse name is going to be my double. My double, as in a double value. It's going to be a variable, and the data type is going to be, you guessed it, a double. The other parameters needed are, I can make it writable. Oh, I don't know if the Milo server, well, let's see. The Milo server might actually not be writable, but I'm gonna try. The minimum sampling intervals has to be 0 or -1. I don't want to limit the subscription frequency. Sometimes that value gets overridden by a very large and slow poll. So I'm going to save these, and that's my double. But I'm going to map it to a different device, which I'm going to call an OPC UA client device. And I'm going to select the client adapter. The pool size, in this case I'm very careful, because in OPC UA client, the pool size is the number of client connections. Some servers have a limit on it, so I'm going to put pool size 1, so it's going to only create 1 session. By default, we actually include the Milo address, so I don't actually have to type. It's very good for demos. We don't use any security. We could, but it becomes, a lot of, I have to type passwords and stuff. So this is the address of the Milo server. If you're curious about it, I can actually show you what the Milo server looks like when I connect to it. It's out on the internet, like our EdgeX, and it contains a number of interesting objects and data points that you can use to actually test a client, for example. It's not as fast as the EdgeXConnect, but it will probably do the job. So it has all kind of things that you can use for testing. I'm interested in these dynamic things because I want to see things move. There it is. So this random value, remember, this is from the Eclipse OPC UA demo server, which is somewhere on the internet. Whereas I want to map, where's my studio? I want to save this. Now I have the OPC UA client device. I want to map my double to that dynamic random double IO point. And of course, as you can expect, the default in EdgeX, you don't have to type, but basically you're looking for the node ID, the type, whether it's a string or numeric. That there's going to be information on how to configure these, and then namespace that node. These are the required OPC UA information to subscribe to a node, like UA Expert does. See, it's namespace index 2, which is dynamic random double is the node ID. So now that I have these mapped, means that my umati machine gets is double information from a remote OPC UA server. I saved it, and now I deploy. And when I deploy, I'm going to wait for this connection to go down eventually, and then restart. The server is restarting. When it restarted, we lose the connection on the client side and restore it after a few seconds. See, it lost the connection for now. Now it's coming back, so the server is back. Now, just bear in mind that the EdgeXConnect runtime only restarts the UA server. Everything underneath it, all the other services are running. It's just the endpoint for the UA server because it needs to redraw or redefine the address space. So I'm going to rebrowse the address space so that now I still have my machines. Sample machine tool, production. Might need more real estate here. And in the production, there's the active program. But the active program now has a new entry, which is the myDouble variable, as opposed to the number in list property. And that random double should be mapped to the same things, which of course it's a little bit behind in the simulation, and some of the the values are, because it is a simulator, but it's basically getting the values buffered with 4 or 5 values behind, but you get the idea. So now that my machine, which is compliant with the umati specification, is mapped to a Modbus endpoint, an OPC UA endpoint, and of course, a simulator, like internal simulator endpoint. That's all there is for creating an OPC UA server that is compliant with the companion specification, the umati machine tool in this case, and how you create that and you configure and deploy in a running EdgeXConnect server. At this point, I'm going to defer other details on what EdgeXConnect can do to our website. That you get links after this webinar. But just to give you an idea, there's more videos on under our product page. And there's a getting started demonstration that tells you how to install the trial version that you will be able to download after this. There's a feature demonstration. This feature demonstration also goes into similar details as I went through now, but also shows other things like how do you create a method, and you create a method handler without having to compile any code. It is something that EdgeXConnect does, unlike our competition. So I'm going to be ready to take any questions on some of the details, and if need be, I can come back to this model, and I'll pass the ball to the moderator. Thanks again.
All right. Well, hopefully that was clear and interesting demonstration of EdgeXConnect. Again, hopefully it came across clear the key points I mentioned in the beginning of the webinar that we were trying to show in this demonstration. I just have one slide, and then we're in Q&A, and I appreciate most of the people have stayed. We've lost a few, but most of the people have stayed. Please use the Q&A. If you have questions, we'd like to answer your questions, have some dialogue there. Just this slide is just summarizing the value and benefits of EdgeXConnect. I think I touched on most of those earlier, but it's with EdgeXConnect, you're on a path to stay current. You're on a roadmap that, as we evolve, and it will evolve, EdgeXConnect, we'll be adding new features in the future. We have alarms and events coming up. Events is a key thing that we definitely have on our roadmap. It's going to be probably one of the nearer term features that we add. And there's history and pub sub. It's very going to be much market driven, but we will evolve the solution. And so that's something that's, I think, very important. You develop your own server, and the maintenance is oftentimes what kills you. Fast time to value. With EdgeX, you can have a server up and running and deploy with your equipment in a short period of time, a lot shorter than if you were to start and develop your own server. And the ability to comply with all industry standards is a big plus, and the flexibility of having access to all those information models and mapping those to your equipment and creating a model that fits your equipment that aligns with the industry standards is also of great value. EdgeX is very extensible. We showed you some of its extensibility with adapters connecting to a couple different data sources, how it can model things, but it's also has adaptability on the say north side, a client adapter capability. We don't advertise that too much at this point, but because OPC UA is the standard that's available today out of the box, but we do intend to expand in that area, adding other northbound data interfaces like MQTT in the future. So the product will evolve, but it gives you a good start with OPC UA. And that's the end of our presentation. We're now into the Q&A. Again, please post your questions in the Q&A box. Next steps you can see on the screen. There's a link. Well, the link's not going to. We'll be mailing this presentation out, so you'll have a link to our website where you can download the EdgeXConnect trial. Again, that's a full feature trial. It just will run for a limited amount of time before it stops, but it has all the features. So you'll be able to implement what was shown in the demonstration today, or just play with it. Out of the box, you'll install it, and immediately you get, if you have a client like UA Expert or any other OPC UA client, you can connect to the server and start seeing values that are running in the simulation. And you can play with that model and do a lot of things in simulation with very little effort, as well as connecting to any other OPC UA data source or Modbus. And there's an email address there if you would like to contact us to have further discussions about your plans for adopting OPC UA and discuss how EdgeXConnect could be a fit for you.
We have a couple of questions.
Okay, very good.
Yeah, I'm gonna take them, these costs. Somebody asked, you can see in the open questions, in the list of I/O devices, would a machine builder specific adapter, as for example, appear in this list? Can you define what is the I/O device list? So the answer is that there are adapters that we are going to develop, and they're going to be available in our list. For now, we have 2 Modbus and the OPC UA adapters. If a third party or a machine builder decide to write an adapter using our adapter SDK, they may or may not decide to publish that adapter for others. So if it's going to be available, we're going to include it in the list of third-party adapters. But if they won't share it, then they keep it themselves. We're going to work on other adapters, general purpose like Ethernet IP and things like that. But usually, a machine builder would write an adapter to their specific platform with our SDK. They can do it themselves. We can do it with them, and then how that is marketed, it's up to the builder itself. And of course, yeah, if you have any feedback on adapters or which adapters you would like, you can let us know. Another question, more interesting, which is a follow-up to a previous question by Stefan Klause. Stefan is asking, is it also possible to create OPC UA objects via methods with the scripting that I mentioned? So if I can share my screen, I'm gonna kind of catch 2 birds with one stone. And previously, Stefan asked about the support for events and or methods, to get the server to trigger events. I'm going to share my screen. Which screen? This guy. And we do not support events yet. That's going to be our next minor release. Although you can see that the system allows you to configure an object as per the OPC UA specification as an event notifier, but the runtime will not actually handle that event because it's a working feature. Once we have that will allow us to actually have custom event triggering, and of course a full support for state machine, which is something that we care about. As far as methods go, that's the one thing about EdgeX. You can model objects, variables, like we saw. You can map a variable. You can also set a constant value, so you don't have to map it. You just set it to something interesting, and it will show as a constant value. But you can also model methods. And as a method, you will have to configure input and output arguments. And for the handler, we support the Lua scripting. the editor, you know, we're gonna improve these. You know, this is functional and not sexy yet, but basically you can and I have a full video on our website. You will receive the link after to our website after this webinar. So the method is basically you implement a Lua function called execute method, and you do whatever you want here. It's at your own risk, so to speak. You know, the method will run its own thread and everything else, and you can handle input and output parameters, do things that you wish, you know, to the values of your system. However, Stefan was asking about the ability of creating a script that can create objects dynamically, I suppose. And the methods won't be able, you won't be able to do that. That's an advanced use. But just to give you a preview, that requires a longer discussion, but it's more than unusual. But whatever Studio does, the EdgeXConnect runtime supports via a CLI, command line interface, and there is also our own RPC API, which we do not, probably we only share on a case-by-case basis. But you can interact with the runtime system through that API externally, not via methods. So you can create, you can script the creation of the system that way. The one limitation as of now we're working on it is the fact that whenever you change the address space, you actually have to restart the UA server service. In a future release, probably not next one, but sometime longer, we'll allow for changes to the address space without having to restart the UA server. So because of that constraint, adding object to a method is not supported at this point. I hope that answered your question, Stefan. Of course, if you need more clarification, you can contact us, and I'll be happy to talk to you. So that was all the three answers. I have, okay. All right. So that's those were all the answers. For the method implementation, there is a feature video, as I said. I don't see any other request. The one thing that I wanted to mention, I skimmed over again, that would grant a different video about UA security and authentication. It allows the user to be authenticated, and the runtime will authenticate against the hosting operating system. In Linux, it also supports LDAP. It's a separate, not a separate, but it's a switch in the installation program, if I would say. But in general, whatever user the OS is using, that will be authenticated by the server. That's it. I'm going to pass back to Stan so we can finish with the poll.
Yes, thank you. I did launch the poll. So for those that have stuck around, and I see quite a few have, if you can take, it's only a couple questions. If you could answer those, we appreciate the feedback. Also, I posted in the chat the link. I mean, I'm sure you could find it on our site, but I gave you the direct link for the download of the free trial. So if you're interested, you can copy that link and go there now and pick it up and start playing. And I think that's it. I don't know if anybody has any other comments from the panelists. We appreciate the support of Umati and Goich joining us. Very much appreciated. We'd like very much to help your members be able to adopt OPC UA and the machine tools standard. I think EdgeX offers an option to do that quite efficiently.
Thank you, Stan, for having me. Yes. And if you have any specific questions to the companion specification, not only machine tools, but any other companion specification, please reach out to me. If I cannot answer directly, I can connect you to the relevant persons.
Appreciate that. Yeah, I guess I know you're very well connected over there with probably VDMA as well and all those activities.
That's correct.
All right. Well, then with that, I think that concludes our webinar for today. Appreciate everybody's attendance and look for some information coming out. We'll send the PowerPoint so you have a copy of that. And please take the opportunity to download EdgeX and look at the videos on our site as well. Thank you very much.